thing tonight. So again, we are reviewing for summative number 1. Okay. The homework check is due tomorrow. The questions I am most worried about on the quiz, I put on the review, but everything is not on here, okay? So you need to have done the practice. All right. So the first section on tomorrow's quiz has all your basic SOHCAHTOA stuff. I did not put an example of each kind on here. I just put a couple application problems so we could practice those. I'd feel really good if there weren't phones out. An airplane climbs at an angle of 18 degrees with the ground. Ground climbing 18 degrees. So it's like it just took off, or it's midair, it's climbing, but anyway. Find the ground distance the plane travels as it moves 2,500 meters through the air. Where do I put 2,500? Okay. And where do I put X? Everybody good? Ground down here, through the air here. Okay, we have, oh, really? The pen's not going to work in here either. That's supposed to be an A. We, from this angle, are talking about adjacent and hypotenuse. So I'm using what? Cosine. I know the angle is 18 degrees. And that would be adjacent over hypotenuse. So this time when I cross multiply, I'm just multiplying those numbers, right? 2,500 times the cosine of 18. I got 2377.6. Making sure my calculator is in degrees, okay? 2377.6. Now the directions to this particular problem say round to the nearest meter. So that would round to 2378. I don't know what it says tomorrow in the quiz. I don't remember if it says nearest something or 10th. If it doesn't say, just go with 10th. Questions? Damsel in distress, being held captive in a tower. The knight in shining armor puts a ladder up to the tower. Okay, he is on the ground 15 feet from the base. Okay, when the knight stands 15 feet from the base of the tower and looks down 15 feet, okay. The angle of depression is 50. Okay, do I put 50 right in here? Is that where angle of depression goes? No, never with a vertical line. It's either got to be with this line or this line. So when her eyeballs are up here, she has to look down 50 degrees. You could put a 40 in here, right? Because that would make a 90, but I usually just go that the angle of elevation is also 50 then. All right, what are we looking for? How long the ladder means we're looking for the hypotenuse here. And we happen to also have adjacent again, yes? So this time it is the cosine of 50 degrees equals 15 over x. So this time when I cross multiply, 15 times 1 is 15. And go the other direction, I get 15 cosine of 50. Yep, pen's working really crappy. So what do I have to do to solve for x? Yeah, I have to divide both sides by the cosine of 50. So I end up typing 15 divided by the cosine of 50. and getting 23.3. Feet, wasn't it? Okay. The one thing we didn't review, for example, say you wound up with a tangent ratio of like 7/8. Do you remember how to find the angle? Because I didn't review that with the other class either, I forgot. Because there's only 2 examples on here. Remember how to type this? Second tangent, and then whatever the ratio is. You get like 41 degrees, 41.2. Okay, that's just a separate example reminding you how to type that. Okay, can't even get it to write that. All right, actually, can we do 5 and 6 first, just to review the easy kind first before we get to the gross kind? When you have a 45, 45, 90, it's x, and x square roots of 2. You're supposed to have that memorized. So if this is 7 square roots of 2, each of these are 7. When you have a 30, 60, 90, it's the short leg is across from the 30. Then if you call that x, because I can write an x square roots of 3 goes on the long leg. I can't write that apparently. Come on. And then 2x is the hypotenuse. So on this picture, we're given the hypotenuse. So that's 2 times the short leg. Okay. If 8 is 2 times the short leg, which is the short leg in this picture? Okay. So if we divide by 2, we get 4. And then once you know the short leg, how do you get to the long leg? Multiply by the square root of 3. So this would be 4 square roots of 3. How we doing? Can do that kind? Okay. Unfortunately, it's possible that one on the quiz is more messy. Again, this is actually giving us the short leg. So we need to double it to get the hypotenuse. What do you do, square root of 6, when you double it? You just get 2 square roots of 6. Okay. But then to get to the long leg, you take the short leg times the square root of 3. What's square root of 6 times square root of 3, guys? Square root of 18. And what perfect square goes into 18? Not 6 or 3. 9 goes in there 2 times. So you'd end up with 3 square roots of 2. Okay, I'm going to pause the video. All right, so this pattern again is supposed to be x, and x square roots of 2. But that has no square root of 2 there, right? So do you remember what we have to do? We have to say this is equal to this and then solve. So 6 is somehow equal to x square roots of 2. If I divide both sides by square root of 2, I get 6 square roots of 2, which I have to rationalize. 6 square roots of 2 over 2 simplifies to what, guys? 3 square roots of 2. So each of these are 3 square roots of 2. Okay, I don't know that they're super tricky on the quiz tomorrow. I would consider particularly number 3 gross, but I guess 4 was just as gross. Any questions on those? All right, the second section of the quiz is on right triangle trig, particularly knowing all 6 functions. So you should have memorized sine, cosine, tangent, opposite over hypotenuse, adjacent over hypotenuse, tangent is opposite over adjacent. And then you should also know what? This flips over and becomes cosecant. I can't write, so the tablet is no help. Cosine flips over and becomes secant. And tangent flips over and becomes cotangent. Okay? Write it at the top of your quiz if you need to, but it will make things go faster if you have those clearly somewhere in your head or on your paper. All right. There's two ways you can do these problems. The first way is to use your special right triangles. It's the way the directions say to do them, but I will tell you there's a shortcut. If this is a 30, 60, 90, and you know the hypotenuse is 6, you have to cut it in half to get the short leg. So B would be 3. And the long leg would be what? 3 square roots of 3. All right. From the 60-degree angle, because it says 60 here, so our little smiley face is up here, we have opposite, adjacent, and hypotenuse. So secant is what? Cosine is cos, so secant is hypotenuse over adjacent. Everybody with me? So we'd have 6 over adjacent to the 60 is the 3. Oh, good. That just reduces to 2, right? Not thinking this one's going to be quite as fun. Cotangent. Cotangent. Instead of opposite over adjacent, it's adjacent over opposite. So the picture up here, adjacent, opposite. Okay, what happens there? Well, these 3's can reduce out, but we still have to rationalize. Anybody know what that's going to become? Square root of 3 over 3. Is everybody okay, or are we still struggling with that idea? Okay, grab your unit circle sheet. What is the ordered pair at 60? One half square root of 3 over 2, guys, is that right? Okay, so the secant is the flip of cosine. So if you flipped this over, you would get 2, yes? The cotangent is x over y, so you would get x over y. Is that the same thing we got? So while you're supposed to use this, am I going to know if you went to the unit circle and used this? Okay, either way. All right, let's do this one. If this is 5, is that what that says, guys? 5? That would be 5 and 5 square roots of 2. All right, we're talking about this angle down here. Sine is opposite over hypotenuse. So we'd have 5 over 5 square roots of 2. What's that going to reduce to, guys? Square root of 2 over 2. Because I'm kind of hoping some of you have it memorized that the point at 45 on the unit circle, whoops, is square root of 2 over 2, square root of 2 over 2, right? So the sine is the y value, square root of 2 over 2. We good? Actually, this one is easier from the triangle here, because secant, you'd normally have to flip one of these guys over. But if you look at this picture, secant is hypotenuse. Let's see, secant is a flip of cosine. So it's hypotenuse over adjacent. Did I get that right? So hypotenuse over adjacent is just going to reduce to square root of 2. Whatever you use, whether you use the special right triangles or you use the unit circle, I'm not going to know the difference, okay? But they're good. This particular section of the quiz deals with first quadrant special right triangles. It is not talking about sines. The same with this question. It doesn't say, we don't have any clues what quadrant we're in, and it doesn't matter. We just have some random triangle whose secant is 11/9. Well, cosine is ka. This is the one I messed up. I wrote co, C-O-H, and no one said a thing until I was done with the whole problem. Okay, ka is cosine adjacent over hypotenuse, so therefore secant becomes hypotenuse over adjacent. Everybody good? So this is the hypotenuse, this is the adjacent. Hypotenuse here, adjacent, opposite. All right. 11 is the hypotenuse, adjacent is 9. We need cosecant. Cosecant is the flip of sine, which was opposite over hypotenuse, so cosecant is hypotenuse over opposite. Everybody with me? Or you want to slap me right now? Am I going too fast? Okay. We need hypotenuse over opposite as our answer, but what are we missing right now? Opposite. How do we have to find opposite? Yes, we know the hypotenuse squared equals leg squared plus other leg squared. I'll just call it x. So if we subtract 121 minus 81 is 40. So the square root of 40 is x. What perfect square goes into 40? Yeah, 4 and 10 is it. So this is 2 square roots of 10. Okay, so all they wanted was cosecant, hypotenuse over opposite. If only that was a nice answer. Hypotenuse over opposite. Hypotenuse over opposite. So what do we have to do? Just multiply by square root of 10, so the top becomes 11 square roots of 10. What happens on the bottom? Square root of 10 times square root of 10 is 10 times 2 is 20. Can we reduce that? No, the 10 is in the radical, the 20 is not, so those don't reduce, and 11 and 20 don't have any common factors, so this is the answer we were looking for. Okay, if you thought that one was ugly, unfortunately, this one is even more disgusting, and I don't think it's this disgusting on the quiz, so I'm going to kind of go fast because I want to get to more important stuff. So cotangent is what over what, guys? Yeah, instead of TOA, it's adjacent over opposite. So if I put 8 square roots of 17 and 17, secant means I'm going to need, let's see, that's a flip of cosine. So I'm going to need hypotenuse over adjacent. Does that sound right? Right? Yes? Okay. So we need this hypotenuse. So we have to do leg squared plus leg squared equals hypotenuse squared. You do need parentheses. 8 square roots of 17. Quantity, oops, got to get out of the radical. Okay, stop. There we go. Squared. What was it? Plus 17 squared? Is a really big number that I would not even have a clue how to rationalize. I tried 3, and then it happened to go 3 again, and then I realized 3 went in there again. It just doesn't matter. I'm not going to give you that disgusting of a number. 81 divides in there, guys. 81 is a perfect square. Not 80. Shoot. $81 goes in there 17 times, okay? So it was h squared equals 1377. The square root of 1377 equals the square root of 18 times 81. Just kidding. Last time I try to go fast. 81 times, what is it? 17, right? Square root of 81 is? So we end up with 9 square roots of 17. I promise it's not that ugly. And it actually gets nicer look what happens. Secant is hypotenuse, which is 9 square roots of 17, over adjacent, which is 8 square roots of 17. So it reduces to, okay. You do have to know all the definitions. You do have to know how to do Pythagorean theorem. You do have to simplify radicals, but you're not going to get the square root of 1377. All right. The next section of the quiz deals with switching degrees to radians, radians to degrees, but it also deals with arc length, area of a sector, and angular linear velocity. It only has a linear velocity question. So S equals R theta, you'll have to know. It's on the reference sheet, 1/2 R squared theta, and this one is the one I use for angular velocity. All of those, whatever you're talking about, has to be in what? The theta, or even the angular velocity, has to be in radians. All right, so this one wants length of an arc. So it's S equals R, which is 7 feet, times theta, which is 2 pi over 3. Is it already in radians? Yes, Miss Hofbauer, it is. So I type 7 times 2 pi over 3. I got 14.7 feet. That is S, the arc length. The second question says area of a sector. So it's A equals 1/2 R squared theta, or 0.5 times 8 meters squared, times 135, not done. Because this formula only works if I have what? Radians. How do I change it to radians? Multiply by pi over 180. And there's no need to simplify because I'm just going to do it all on my calculator anyway. 0.5 times 8 squared, not that, 0.5 times 8 squared times, was it 135 over 180, guys? 135 pi over 180? $75.4, anybody? In my crazy typing. And please remember, area is square units. We had meters and we squared them, so we get square meters. Both of those formulas are on the Peach sheet. Brayden, I know you were gone. They're above the unit circle on the Peach sheet. Did you get a Peach sheet? Okay. Everybody knows where to find them? All right, one more. And that's all there are on the quiz on this section. Well, actually, that's not true. You have to do a converting degrees to radians, radians to degrees, but I didn't put that on the review because you should be able to do that. All right, it says the radius is 4 inches, and we know it's turning 1750 RPM, stands for revolution per minute. Everybody good? This is the formula I use. So I need omega, but omega has to be in what? Does anybody remember? Radians per time. So I need to do what to change this to radians? I need radians. What do I want to get rid of? Revolutions. I put it on the bottom because they're canceled. What do you know about revolutions? Look at your unit circle. All the way around, 1 revolution is how many radians? 2 pi. So then revolutions cancel. You could get a decimal. I'm just going to do 1750 times 2 is 3500, isn't it? And then I have a pi that's still there. I didn't pick up my calculator yet, and it's radians per minute. Now it's an omega for an angular velocity. So I have 4 inches times 3500 pi. Don't lose your pi. You're going to type it in on this step now. Radians per minute. Okay. So currently my label would be inches per minute. What do they want? Well, we got lucky. They just want feet per minute. So what do I need to get rid of? Inches needs to go in the denominator, and it needs to become feet. What can you tell me? First of all, what's the number? 12? Please tell me you know some of this. 12 inches is a foot, so the 12 goes with what? The inches. Now the inches divide out. The only labels I have left are feet and minutes because radians magically disappear. Revolutions don't. That's why we had to cancel them by changing it to radians. All right, on the top, we have a 4 times 3,500 times pi. In the denominator of this particular question, all we have is a 12. So this is what we need to type. If you have two things in the denominator, the parentheses become especially important. 4 times 3,500. Don't forget the pi. And then we just had to divide by 12. 3665.2. Label. Feet per minute. Now, if you rounded, like if you had typed this in and used that decimal, you might have a different decimal at the end, okay? I know that, and I will allow for different rounding on those, just so I can follow your calculations. Please make sure you have done that homework assignment, okay? The last section of the quiz, it's not the last, it's 2 sections put together. On the quiz, it's 2 separate sections, okay? 4.3b is this part. This is 4.3b, and it goes through 26. That's 4.3b. Okay. I don't have time to do all of these. Can someone remind me what? It's just cosine is the x coordinate and sine is the y coordinate. Okay. And tangent is what? Y over x. And then the reciprocal ones, you would have secant. If you flip the x over, you would have cosecant if you flip the sine over, and you would have cotangent if you did x over y. All right, so go to 7 pi over 6. Tell me the ordered pair. Negative square root of 3 over 2, negative 1/2. This is using the unit circle, guys. So which one of those is the sine? The negative 1/2. All right. If you want to think in degree, oh, gross, 3 negatives. Well, let's do this one. This one's easy. Negative 180. Do you know where that is? Same place as positive 180, right? So the ordered pair is negative 1, 0. Did I do that right? So the sign is just 0. Okay, pi over 4 is how many degrees? 45. So it's actually saying negative 45 degrees. Can you find that one? You could add 360 and you'd get 315. It is square root of 2 over 2 and negative square root of 2 over 2. So how do you find cosecant? You flip over which one? Flip over that guy. All right, so cosecant becomes 2 over, and it has a negative square root of 2. Do you remember what those rationalize to always? You get 2 square roots of 2 over 2, which is just negative square root of 2. That's a hot mess of work. Sorry. If you change this to degrees, You get negative 150. Where's negative 150? Well, you could add 360 and you'd be at 210. Is that right? 360. I can't even write a 6. Okay, so tell me the ordered pair at 360. No, at 210. Just kidding. Ordered pair at 210. Negative 1/2 negative square root of 3 over 2, or do I have that backwards? I'm backwards. Okay, cotangent. How do I do cotangent? X over y. And do I worry about the denominators? No. So it's negative square root of 3 over negative 1, which is just square root of 3. All right, there are 4 more of those on your sheet. I don't know. I don't think maybe one is okay. 0, the ordered pair is 1, 0. So the cosecant is what? Cosecant is the reciprocal of sine. What is the reciprocal of 0? Yeah, it's 1 over 0, which is undefined. Okay. Is that enough choices? Practice? I can finish them up before I post the notes. The answer key will be posted anyway, and it has all of them done. All right, I'm going to go back here real quick, and I am going to do these quick because they just want the reference angle and the quadrant. I'll start with 30. It's clearly stopping in quadrant 1, yes? And it wants the reference angle to the x-axis. So if you have negative 705, anybody know what that reference angle would be? You could add 360 until it became positive. You would get 15, I think. Is that right? So it is 15 degrees is the reference angle. Let me just do an easy one. If you had 97 degrees, what's the reference angle? Guess what? These are multiple choice on the quiz. One choice is going to say 7. One choice is going to say whatever that is. Is it 7? No, it's got to be to the x-axis. So 180 minus 97, is that 83, guys? Okay, so that was just an example. Negative 167. If I add 360, somebody really fast. What is it? Okay, so if I add, I'm at 193, because it's the same place. Okay, negative 167 or positive 193 are the same place. What's the angle back to the x-axis here? 13 degrees. Okay. The radian ones you have to answer in radians. Like I said, I think they're multiple choice, so the choices will all be in radians. But if I change this to degrees, because that's the way my brain works, what's 15 times 45, somebody? Or you can do 15 pi over 180 times 4 pi. The pi's will cancel. Anybody? We're wasting time. We could be doing the hard ones. I got nothing. Uh, 675. If we subtract 360, we're at 315. Can you find 315? What quadrant is it in? Quadrant 4, or you can write the regular 4, I don't care. Look at your unit circle. What's the reference angle if you're at 315? Anybody know? Is it a 30, 60, 90 or a 45, 45, 90? It's 45 degrees. Use your unit circle again. What is 45 in radians? Pi over 4. If you got a really ugly answer, like 12 degrees, how would you change it back to radians? You'd multiply times pi over 180, right? It would be like pi over 15, I think, if it was 12 degrees. All right. Does that take me to the last section? Last ones? Or did I skip something important? Okay. On these last ones, these are the ones where they give you the clues and you have to draw it in the right quadrant. Okay? If the tangent is positive 2 and the sine is, what does that say? Which means positive. Cosine is positive. So where's everything positive? Okay, so the answer to the quadrant is 1. Then how do I label tangent? Well, first of all, I'm going to make it a fraction so that I can label opposite over adjacent. Can I do Pythagorean theorem in my head real fast for you? Square that, you get 4. Square that, you get 1. Square root of 5. And I don't know, what if it asks for sine? It only asks for 1, by the way. Sine would be opposite over hypotenuse, or 2 square roots of 5 over 5 after I rationalize. I'm more concerned that you can draw them. I assume you could find any function I asked for. I'm kind of scared assuming that, but okay. 34 says cosecant is 2. What is that also telling you then? Sine is 1/2, positive and flipped over. Okay, it says here the sine is greater than 0. Yeah, we already got that. And then it says cosine is less than 0. So where is the cosine negative? All students take calculus. Cosine, and it even says it on your unit circle. Okay, where is the cosine negative and the sine is positive? Can you find it on the unit circle? Because it says in the little doesn't it say right up here? Okay, those little print. What quadrant would we be in? Sine is positive, cosine is negative, is quadrant 2. Okay, opposite over hypotenuse is 1/2. What do I need to know if I'm in quadrant 2 though? What is this x value going to be? Negative. Yes? Okay, this time when I do leg squared, I don't know the other leg. So this time I have to subtract. So 4 minus 1 is 3. This is square root of 3. But because it's going left, I have to put it as... Am I doing this right? Did I mess something up or are we good? Cosecant. Flip of that is sine. Opposite over hypotenuse. The sine is positive. Okay, I think I'm all right. What do you want to find? What function? Secant. Okay. Secant would be, well, cosine would be adjacent over hypotenuse. No, that would be adjacent over, try that again. A cosine would be adjacent over hypotenuse. So secant would be hypotenuse over adjacent. Good choice if you want a disgusting answer, right? 2 square roots of 3 over 3, but it's negative. Okay, would have been a really nice one to pick, like, actually I don't think any of them were going to come out very nice. Well, let's see, adjacent over opposite, cotangent would have been negative square root of 3 over 1. All right, one more. Sine is, that says negative, right? And cosine is, okay, find it on your sheet. All students take calculus. The cosine is positive down in quadrant 4. You can write a 4, I don't care. Okay. Sine is opposite over hypotenuse. Which one of those gets the negative? It's never the hypotenuse. But didn't we go down 1 right there? Okay, when I do Pythagorean theorem, hypotenuse squared equals legs squared plus other legs squared, it would get 24, which is 2 square roots of 6. Positive or negative? How do I know? Because it could be either. I went to the right. All right. What function do you want to find? Not tangent. We could do cotangent, which is adjacent over opposite, which would be 2 square roots of 6 over negative 1. We could do just plain old cosine. 2 square roots of 6 over adjacent over hypotenuse. Is that enough practice? Okay. You must finish all your Delta Math, put your homework check together. You are to attach worksheets 3 through 10. There are extra copies of the review in back if anybody wants to take an extra one home and do those problems again. But there aren't that many. You could just copy them on notebook paper too if you really wanted to just. Yes. I do. Is it in the back? Is there one back there somewhere? Okay.